Now we've talked about electric potential and electric potential energy. There's something else that you're probably familiar with that we haven't touched on yet, and that's the electric potential difference. So in many cases, we are interested in finding the potential difference between 2 points. So for example, if the voltage difference between 2 points is 12 volts, then there's going to be 1 coulomb of charge that will gain 12 joules of energy when moved between these two locations. So how can we calculate this? First, let's take a look at a generic electric field. Let's say I have a location A and a location B over here, and I'm just going to take some random path to get me to B. So to calculate the potential difference, calculating the potential difference, we have delta V going from A to B is equal to negative integral from A to B of E dotted with dl. We can actually split this up, in fact, and have negative the integral from infinity to B, E dotted with dl, minus the integral from infinity to A of E dotted with dl. In other words, we can have this rewritten as the integral from infinity to B of E dotted with dl plus the integral from infinity to A of E dotted with dl. And once you do the integrations, you'll find that the signs flip and you get VB minus VA. So then what about uniform electric fields? With uniform electric fields, first of all, I can say that my charge starts here. Kind of do a dotted line to represent that it used to be here, and then it moves somewhere down to this point. So it went from A to B, and this is my charge Q. It moved a distance of D, and it exists within an electric field, E. So our question now is, instead of looking at a general case, we want to see how much we can simplify this if we make sure the charge moves within a uniform electric field. In that case, I have delta V, A to B, equals to VB minus VA. It's going to be equal to negative integral from A to B of E dotted with dl because the electric field is uniform, it's something that I can factor out. And I have the integral from a to b of dl. And that is simply the total length, or the total distance. So this is total distance. And so delta v a to b is going to be equal to negative e times d. Or in general, we have delta v a to b is equal to vb minus va, which is equal to kq over rb minus kq over ra. So then delta v a to b is kq times 1 over rb minus 1 over ra.